got force. Force, simply put, is a push or a pull on an object, like force of gravity, right? It's pulling it down. A load is a force applied to a structure. So in the case of bridge building, you got a car sitting on a bridge. The car is the load because it's applying a downward force on the bridge. Pretty self-explanatory. So, for example, so about any workbooks, I'll use my hat. Hat's on the desk, it's a load, it's exerting a downward force on the desk, but it's at equilibrium because it's not moving. So that means there's reactions. The table has a reaction, so it's applying a downward force. The table, through its supports, the four legs, is applying a reaction against the force. Because as Newton's third law says, for every action there's an equal and opposite reaction. So in the case of the hat, it's downward force elicits an equal reaction from the table to hold it up. I guess the bigger purpose of this is you guys have to write a paper using these terms. This is what I saw on the unit plan. Yeah. I mean, like I said, I don't know what you guys do in class, but I was going off this, that you guys have to write a paper about force, load, reaction, those things. So if you understand the definitions, cap how they're incorporated into bridge building, we can move on. You feel about that? Alright. So this explains the whole idea of equilibrium and reactions probably a little better than I could. So if you wouldn't mind going through this, then there's two questions at the end. They're essentially just, I want you to summarize each of these two passages. Take as long as you need. Do you need a pen? Alright, cool. You just briefly answer each of these questions. I like to do this a lot when I read, is just write a quick, like, 1-2 sentence summary at the end of big sections, just pull out the big ideas. So if you need to jump back to pull it out, that's fine. Just, 1-2 bullet points, just a quick way to remember what each one said. Alright, cool. So, let's have you teach me here. Suppose I don't know anything about a normal force. I'm like, yo, bro, what's a normal force? What would you say?
I would say basically that it's...
How would a table then be able to exert a force if it's a table?
It must be a...
Would you rather work on that dictionary I gave you now or in the last 10 minutes? Because for this dictionary, I'm asking you to create a visual representation, so I'm just trying to give you some images within the class that I'm able to work with here. So my goal with this is, if you guys are talking in class and you don't know what the word is, you can pull it out, take a quick look, and then have some reference. Alright, let's kind of read over your shoulder. Looks good. Just walk me. What do you have for reaction here?
So for reaction, I have what occurs when when a force applies to two. That doesn't make sense at all now. I don't know that. Basically, what it meant was when two forces basically collide together, it has to have a reaction. The item that is basically supporting the other item, it must basically have enough force, so both forces are colliding together in a sense, I guess.
Okay, I understand. Yeah. It was a little confusing reading it there, but it makes sense that way. That when the two forces collide, that would be...
and then it would be
equal. Good, okay. Now just in the bottom of the corner, let's pick some sort of visual representation to show these, be it the dog food on the table, people in the chair, a car on a bridge. Maybe you could use arrows to show the forces that are at play from the load and where the reactions are. Do you think you'd be able to fill in the blanks here with those words down there? Or have you guys not used that terminology?
We have not used the things, but I could probably...
I mean, give it your best shot. If there's blank ones, we could go through them together. Let's start top chord, process of elimination. Where's the top chord not going to be? It's at the top, yeah, the bottom.
I would say this, but at the same time, I think it's going to be like a chord on the actual thing, so...
You're right with your first one. The top chord is the top one going apart. How about vertical?
Vertical, so
again, process of elimination, yeah.
And then bottom chord.
Yeah. What about diagonal? You might actually have to move one around. I don't know if it's cool. Yeah.
This would be diagonal, that would be vertical.
And then the last two are tougher. They're a little bit more advanced terms in terms of the physics of it, but...
And post is that, and then the... No, that's the hit vertical, and that's nice.
You can hold on to this. I will have the page with the other words for tomorrow on there. If you want to hold on to that, you can. I think the diagram might be a little helpful in terms of giving you a depiction of it. Do you want these? I mean, I kind of just threw them together. If you want to hold on, you can. I'll take them. I'm going to toss them if you don't want them. So it's a resource you can use. Let's see here. Let's make sure. How about you give me some feedback? I keep finishing early, so I think it's pretty obvious I'm rushing or not playing enough. But what else do you think I could be doing better for you?
No, it's just that I don't like doing things for that long of a period. Let's just put it as that.
Yeah.
So it's
Okay.
kind of like that.
Give me some feedback though. What can I be doing better for you?
Well, the speed is perfectly fine.
Okay.
It's, I don't know. This is the thing. If you can get a quality product for the fastest time, why not do it?
Okay. What do you think about the activities we've done? We've done a lot of like reading, packet stuff. Is that boring? Is that interesting? Would you like, more design challenges like that? What would get you interested,
I
more
would
engaged?
say